All right, now let's get into some logarithmic functions. So now we're going to be graphing the logs, and this actually is way out of order, so I apologize for that, but at least you guys have the document. So in this case, we have a logarithm. Again, this is a logarithm that the parent graph is going to look like this. Remember though, now this has a vertical asymptote where exponential had a horizontal. But in this case, now you can see we're just reflecting about our x-axis. So now the graph, oops, let's kind of redo that. Now my graph is going to look something like that. And so we can say my domain is going to be from 0 to infinity, right? There's no negative numbers in this case. And my range is going to be from negative infinity to infinity. This logarithm has a reflection about the y-axis, and then also my shifting my graph up one. So we go to the parent graph, sketch that parent graph. What we're going to do is reflect this about the y-axis and then shift it up one. So it's going to be reflected up here and then shifted up one. Now notice in this case that my y-intercept does not change based on these transformations, right? If I shift it up or down or do a reflection, that's not going to impact my reflection. However, my domain has changed, right? My domain is the set of all y values that make up this graph. It's going to be from negative infinity to 0, but my range is undefined, or is not impacted, so that's negative infinity to positive infinity. Over here, again, sketching my parent graph. Now we're just going to do some basic transformations, right? So in this case, all I'm doing is shifting the graph 3 units to the left and then 4 units down. But what's also important, what transformed is my vertical asymptote, right? So that's being shifted over 3 units. So it's going to look something like that. And then, so my y-intercept went left 3, so 1, 2, 3. And then everything, then that point is also going down 4 units. So 1, 2, 3, 4. So it's going to look something like that. All right, now what's interesting about this is my domain, again, got impacted because it can't go beyond that y-intercept. So now my domain is from negative 3 to infinity. I don't know why I didn't write negative 3. I said it, but I didn't want to write it. So that's negative 3 to infinity. And my range is going to go from negative infinity to positive infinity. So negative infinity to positive infinity. Here I have a natural logarithm, which again, guys, is still going to have the same base, right? It's gonna, or I'm sorry, same y-intercept, same vertical asymptote, but now this graph is being shifted 2 units to the right. Just remember, ladies and gentlemen, the y-intercept, or the, I'm sorry, vertical asymptote is also being shifted 2 units to the right. So now that graph is going to be over there. My x-intercept is being shifted over 2 units to the right. So now that graph is going to look something like that. So now I can say the domain is going to be from 2 to infinity, and my range is going to be negative infinity to infinity. All right, in this case we have the 1/2. That's going to be a vertical compression, okay? In this case, it's not going to impact my domain and range. It will impact what the graph would look like, but again, you can always test it with points. I'm just want to go into the general idea of the transformations, so you guys can see what those graphs would be. But I will show you how you can identify what to do when you have a vertical shift or compression, I'm sorry, vertical stretch or compression if you needed to find a point. So in this case, we have our y-intercept, or I'm sorry, our x-intercept is going to be the same, right? And then now you can see that the only thing that's really happening is my graph is being shifted up 3 because that's adding a 3 on the outside. So I'm going to take this graph, so 1, 2, 3, and just move it up to there. Let's go ahead and use a green. So the graph basically is going to look exactly the same. Going to have this nice little vertical asymptote though going on here. And if you wanted to find like an additional point, what you want to do is find a number that 2 raised to what number is going to give you a integer. So in this example, you know, we want to pick positive numbers. But I'd want to get something that is going to be divisible by 1/2. So for instance, if I said like y of, I don't know, let's do 2, right? So if I plug that in, I'm going to get a 1/2, not 2, I don't want to do 2, let's do 4. I was thinking of the answer 4. I was thinking of the answer to get to. So if I had to say log base 2 of 4 plus 3, okay? So that's going to be 4, so that's going to be over here, so that's 1, 2, 3, 4. That's what that point's going to represent. Or that's the x value of that point. So 2 raised to what number equals 4? That answers 2. 2 times 1/2 is going to be 1. 1 plus 3 is 4. So over here, 1, 2, 3, 4. So at 4, you could see my point would be just like that, right? And then again, you could also do like 8 and whatever else if you needed to like find some coordinate points. But that's what you basically do when you have a vertical stretch or compression and you want to be able to identify more coordinate points to get the idea of the shape. But I don't really take too much into that. I really want my students just to focus on transformations, but there you go. So in this case, my domain is from 0 to infinity, and my range is going to be from negative infinity to infinity. All right, the last one is natural logarithm, but again, we have a b inside our transformations, so this one's going to be very important. What we're going to want to do is rewrite this as a 2 times a x minus 1. Okay, now it's very important that this 2, just like on the outside on number 5, that actually vertically compressed my graph, the 2 is actually going to be horizontally compressing my graph. And what that's going to do is that's actually going to change what my new y-intercept or my new x-intercept. I keep on saying the wrong thing. I apologize for that. So my parent graph looks something like this, right? So if I want to find out what my new x-intercept, because a lot of students will see this, that's a +1. I don't know why I wrote -1. Sorry about that. So a lot of students will see this and say, all right, we're shifting left 1, which we are. So the new y-intercept is going to be at -1. But what's going to be the new x-intercept? It's not going to be at 0. So how do you find the x-intercept? Well, remember, the x-intercept, let's go back to blue. The x-intercept is when y is equal to 0. So if I have 0 equals ln of, let's just write it like this, 2x plus 1, right? Remember, this is base e, so this is technically e to the 0 equals a 2x plus 1. Well, what's e to the, actually, what it was? So what is e to the 0? Well, e to the 0, I forgot to use my parentheses, is going to be a 1. Now again, if you apply your distributive property here, that's going to be a 2x plus 2. Now subtract your 2 on both sides. You get a -1 is equal to a 2x. Divide by 2, divide by 2. X is equal to a -1/2. So instead of actually shifting it, that left, or to be at 0, thinking it's going to be a -1, it's actually going to be at x equals a -1/2. That's what that horizontal compression is actually doing with this graph. So the graph, going back to green, is actually going to have a y-intercept at -1/2. But again, that doesn't really matter for my domain and range. I just wanted to make sure I added that for you. So I'm just going to write that in there. So -1/2, 0. So I'll put that in there for you guys so you can at least see that. A lot of students will make that mistake. So my domain, in this case, is again, your domain can only go as far left as your y-intercept, which is still going to be at -1. So that's going to be -1 to positive infinity, and my range is going to be negative infinity to positive infinity.